Hello everyone. In this video, we will learn about the 30-60-90 triangle theorem. This is the part 2 of the 30-60-90 triangle theorem. So let us start. Now see here 30-60-90 triangle theorem. This is the part 2 of this theorem. Part 1 we have already proved in the previous video. I will give the link of that video in the description and the I button. You can check it out. Now here we will prove the part 2. Now the statement of this theorem is, see, if the acute angles of a right angled triangle have measures 30° and 60°, then the length of the side opposite to 60° angle is root 3 upon 2 into hypotenuse. Okay. See, here there is a 30-60-90 triangle. That means it is a right angle triangle having the measures of acute angles as 30° and 60°. Okay. Then the length of the side opposite to 60° angle. So here what we have to prove, the length of the side opposite to 60° angle. Okay, that we have to see in part 2. Okay, see here in part 1 of this theorem what we have seen, the length of the side opposite to 30° angle. Okay, here 30° angle we have seen. In part 1 we have seen the length of the side opposite to 30° angle. Okay, now in part 2 we have to see the length of the side opposite to 60° angle. Okay, that is what it is, root 3 upon 2 times the hypotenuse. Okay, understood? Now we will see what is given. Okay, from this statement we will write what is given. In the part 1 of this theorem we have seen how to write the given, right? So here what is given, if whatever part of the statement is there till then. Okay, so the given part of the theorem is, the acute angles of a right angle triangle have measure 30° and 60°. This is the given part of the statement. So this means what? In a right angled triangle, the measures of the acute angles are 30° and 60°. Okay, so we have to write the given. So the given is, in triangle ABC, angle B is 90°. Okay, angle C is 30° here, and angle A is 60°. Okay, we have drawn this figure and we have to write this. This is the given. Okay, now next we have to write to prove. Okay, what we have to prove, see here from the statement, after then whatever part is there that we have to prove. Okay, then the length of the side opposite to 60° angle is root 3 upon 2 into hypotenuse. Okay, this part we have to prove. Okay, now see, now the 60° angle is this angle, angle A. Okay, see, this is the 60° angle. Now the side opposite to this 60° angle is this side BC. Okay, this side BC is the side opposite to 60° angle. So we have to prove this side BC will be root 3 upon 2 times the hypotenuse. Now what is the hypotenuse? The side opposite to 90° angle, right? So here AC is the hypotenuse. So what we have to prove? Here we have to prove BC is equal to root 3 upon 2 into AC. Okay. So BC, that is the side opposite to 60° angle, that is side BC, is equal to root 3 upon 2 into hypotenuse is side AC. So BC is equal to root 3 upon 2 into AC. This is what we have to prove. Okay. So we will start the proof. Now we will see the proof of this theorem. Okay, now the first step is, in the above theorem we have proved. See, this is a triangle, 30-60-90 triangle, right? The given triangle. Now we have already proved. See, this is the part 1 of this theorem. In this what we have proved, the length of side opposite to 30° is half the length of hypotenuse, right? So AB is equal to half AC. Okay, the side opposite to 30°, that is AB is equal to half AC. This we have proved in the first part of the theorem. Okay. So for proving the second part, first we have to write what we have got in the first part of the theorem. Okay, the side opposite to 30-degree angle, that is this side. Side AB is equal to half AC. This we have already proved by the above theorem. Above theorem means the part 1 of this theorem, right? See, in exam, if it is asked 30, 60, 90 triangle theorem, you have to write both the parts. Okay, first you have to prove this part, that is for 30-degree angle, then you have to prove it for 60-degree angle. Okay, if in statement it is asked to prove the length of side opposite to 60-degree angle and the length of side opposite to 30-degree angle, then you have to write both the parts. Okay. If only the length of side opposite to 30-degree angle is asked, then you have to prove the part 1, and if only the length of side opposite to 60 degree is asked, then you have to prove the part 2. But we have to write the statement of the part 1. Okay, the length of side opposite to 30-degree angle is half the length of hypotenuse. Okay, so here the first step is, in the above theorem we have proved AB is equal to half AC. Now the next step is AB square plus BC square is equal to AC square. Okay, the reason for this is by Pythagoras theorem. Okay, see, it is a right angled triangle, right? So you can apply Pythagoras theorem, and from Pythagoras theorem, AC square, that is the square of a hypotenuse. This is AC is the hypotenuse. Okay, so AC square is equal to, the square of hypotenuse will be equal to the sum of the squares of the other two sides. Okay, so AC square is equal to AB square plus BC square. Okay, this step, this is by the theorem, Pythagoras theorem. Okay, now the next step is, see, now see here AB square is there, no? Now see, AB square, AB, see, from here what we have got, AB is equal to half AC. Okay, so instead of this AB, you can write half AC, right? AB के जगह पे हम half AC लिख सकते हैं. Okay, see, AB is half AC, so AB square is there, right? So instead of AB we will write, so in the next step we have to write, instead of AB square we have to write this value AB. What is the value of AB? This half AC. Okay, so we will put this value in this equation. Okay, so what we will get, AB is equal to half AC. So here AB square is there, right? So we have to do square of this whole thing. Okay, AB square will be half AC the whole square. Okay, because AB is only half AC. सिर्फ AB का वैल्यू हाफ AC है. So AB square means half AC the whole square. Okay, we have to do square of this whole thing. So after that, plus BC square is equal to AC square. That we have to write it as it is. Okay, till here understood? So instead of AB square, what we have written, half of AC the whole square. Okay, now we will solve this bracket. Okay, therefore, so the square of half will be 1 by 4, right? Square of 1 upon 2 will be 1 upon 4, right? So this half square will be 1 upon 4. So the square will come in this also, AC square. So 1 upon 4 AC square. Okay, so the next step is 1 upon 4 AC square plus BC square is equal to AC square. Okay, we have opened this bracket and we have solved. Okay, understood? Now what we will do, see. Now see, here this AC square term is there and here also AC square term is there. So we will take this AC square, we will take this side of this equal to sign. Okay. So here 1 upon 4 AC square is there. If we take it to this side of this equal to sign, so what we will get? Minus 1 upon 4 AC square. Okay. Therefore, see, this BC square will remain this side only. BC square, which is equal to, here what we have? AC square. Now this, here see, 1 upon 4 AC square is there. If we take it to the right hand side of the equal to sign, then what we will get? Minus 1 upon 4 AC square. Okay. Therefore, BC square is equal to, okay, see, AC square in both the terms it is there, so we can take it common, right? So inside the bracket what will remain, see, here AC square into 1 is there, okay. So 1 minus 1 upon 4, okay, here 1 upon 4 is there. So into 1 minus 1 upon 4 into AC square. So this AC square will come outside the bracket. Okay. See what we have done. We in both the terms AC square is there. So that we have taken common, and inside the bracket what we will get, 1 minus 1 upon 4. Okay. Now we will solve this. So here I don't have space. So I will write it in the next page. Okay. Therefore, BC square is equal to, inside the bracket we have 1 minus 1 upon 4 into AC square. See, from here only I have written the step again so that I can explain it. Okay, BC square is equal to 1 minus 1 upon 4 AC square. Now we will solve this term. Okay, see, 1 minus 1 upon 4. We have already seen how to solve this in addition and subtraction of fractions. So in addition and subtraction of fractions, I have explained how to solve such type of problems. I will give the link of that video in the description and the I button so you can check it out. So here what we have to do, 1 minus 1 by 4. So either you can solve it by cross multiplication or by taking LCM. Okay. So here 4 1 the 4 minus 1 upon 4. Understood? So 4 minus 1 upon 4 will be how much? 4 minus 1 will be 3 upon 4. Okay? Understood how we are getting this? 3 upon 4. Okay? So 1 minus 1 upon 4, we will get the answer as 3 upon 4. So here we will write inside the bracket, instead of this 1 minus 1 upon 4, we will write 3 upon 4. Okay? So therefore BC square is equal to 1 minus 1 upon 4 is what we have got just now, 3 upon 4. So 3 upon 4 into AC square. So 3 upon 4 into AC square. Therefore, BC square is equal to 3 upon 4 into AC square. See here both the sides square terms are there. Okay. Here also square is there and here also square is there. But see, here we want to find out the value of BC. Right. We have to find the value of BC. See here we are getting the value of BC square. And here also square term is there on the right hand side. So what we will do, we will take square root on both sides. Okay. Taking square root on both sides. Okay. See both the sides square terms are there. So we will take square root of it. Okay. So what we will get? See here. I will show it here. See here. If we are taking square root on both sides, what we will get? Therefore, square root of BC square will be BC. Square root of BC square will be BC, which is equal to, see, square root of 3. What is the square root of 3? Will be root 3. Okay. Root 3 upon square root of 4 will be, square root of 4 will be 2, and square root of AC square will be AC. Square root of AC square will be AC. Okay. So understood. Therefore, BC is equal to root 3 upon 2 into AC. So therefore BC is equal to root 3 upon 2 into AC. Okay. So here see, we got the answer. See, we have to prove this. BC is equal to root 3 upon 2 into AC. This we have to prove. And here see, we got the answer. BC is equal to root 3 upon 2 into AC. Okay. So this is what we have to prove. BC is equal to root 3 upon 2 into AC. This is the proof. So this is how you have to prove the 30, 60, 90 triangle theorem part 2. Okay. If you have any doubt in this topic, then please write it in the comments. If this video was useful to you, then please like and share it. And don't forget to subscribe to my channel. Thank you for watching.